Is a cool optimization problem, so let's just solve it. What is the maximum area of an isosceles trapezoid that has legs of length 1 and one base twice as long as the other? So let's just draw this trapezoid. It's isosceles, so the one thing we know is that these two sides are equal, these two angles are equal, and that means that these two angles are also equal. It has this base is going to be x, let's call this 2x, so it's twice as long, and has legs of length 1. We want to find the maximum area of this thing. So first thing is just draw these triangles right here, and these are going to be right angles because they're going to be perpendicular. So the area of this trapezoid is going to be the area of the rectangle plus the area of the triangles. So the way I'm going to do that is I'm going to just call this angle right here, I'm going to call that angle theta. And so using that, we know that, well, this height right here, that's what we're interested in. H is going to equal sine theta, because sine theta is h divided by 1, and so h divided by 1 is h, so h equals sine theta right there. And so basically we just want to find this area using that formula right there. That's h. We also know that this one similarly is cosine theta. This length right here, this length is cosine theta, this length is cosine theta. And so we have this rectangle here, which is an x times h, or x times sine theta. And then right here we have this thing right here that says it's cosine theta. But we also know that this is cosine theta, this is cosine theta, so we get 2 cosine theta, adding these, plus x must equal 2x. And so 2 cosine theta equals x, and so cosine theta equals 1/2 x. But what we're also more interested in is how to write 2x, or how to write x in terms of cosine theta. We know that is 2 cosine theta. So now we have an expression for the area purely in terms of theta. The area is, well, x times h. So x times h plus, well, this is going to be this side length right here, so cosine theta times h. And since there's two triangles, we're technically going to divide by 1/2 and then multiply again by 2, so it doesn't really matter there. So we have xh plus cosine theta h, but now I'm going to replace everything that we just found. So x is 2 cosine theta times h is sine theta, plus cosine theta times h is again sine theta. So this is our equation for the area of this trapezoid right here. So this gives us 3 cosine theta sine theta. And what I'm going to do is write this as 2 cosine theta sine theta times 3/2. And so this is a constant, so I'm just going to factor it out. We want to maximize, we want to find theta such that this 2 cosine theta sine theta is maximized. But 2 cosine theta sine theta is also equal to sine of 2 theta. So sine of 2 theta equals 2 cosine theta sine theta. That's a sine double angle formula. So sine 2 theta, so the area equals just sine of 2 theta times 3/2. And when is sine 2 theta maximized? Well, sine is a function, has a maximum of 1. So the maximum area right here, or this maximum that the sine can be, is 1. So times 3/2, the maximum area is just 3/2. And so that's answer D.